Hello everyone, so today we'll be solving chapter 19 from chapter 4. So let's start with what we do know in the problem. So it reads, the Lamborghini Huracan has an initial acceleration of 0.5 g's. Its mass with the driver is 1,510 kilograms. If an 80 kilogram passenger rode along, what would the car's acceleration be? Well, we know this initial acceleration of the car is going to be about 0.75 g's. The car's mass with the driver is going to be 1510 kilograms, and then the passenger is going to be 80. And we'll represent that by mass of P for mass of passenger. Going to do mass of C for the car right here. And then, of course, what we're trying to find out is what is this new acceleration with our passenger? Well, let's think about this question. We want to go with Newton's second law. That's what matches the most. So in case you didn't remember, it's going to be force equals mass times acceleration. What we're going to see is we're really measuring the force of the engine here. We're using the total mass of the car plus the occupants. That's going to be our driver and passenger. And then, of course, what we really want to solve here is for our new acceleration. Now, we also have to keep in mind of gravity. So the g is being gravity, and acceleration due to gravity is going to be 9.8 meters per second. So meters per second squared, apologies. So, in order to convert from g's to meters per second squared, what we can do first with the initial acceleration is, due to initial acceleration, we know it's 0.75 grams. Or not grams, excuse me, g's. What we'll have from that is 0.75 times 9.8, and that'll equal to 7.35 meters a second squared. That'll be our new conversion. So same acceleration, just different units. Now what we're going to have is we want to also make sure that we get our force now from our mass and our acceleration. So at this point we can do F equals 1510 times 7.35. We keep units in there just to see if they cancel out. Squared. We know this is going to give newtons because force is going to be in newtons. This will be 11,098.5 newtons. So the engine's going to be pushing forward with a force of 11,098.5 newtons, essentially what that's meaning. Now we have to figure out our second mass. That's going to be our driver plus passenger. So going back up here, we can say, let's call our M2 for total. So we have our M of C plus M of P essentially. So M2 equals MC plus MP, which is going to be 1510 plus 80, both being in kilograms. And this is going to be equal to 1590, so 1,590 kilograms. Now we can solve for acceleration. We have our force, we have our mass. Now all we have to do is rearrange the equation, so A equals F over M. What we'll have instead of here just having the regular to make it make more sense, we'll use that as A2 as well as M2 to show that we're using those values. And then we might relabel this as A of 1, not necessarily having AI, so it makes sense. A acceleration 1, acceleration 2. What we'll be seeing with this is we plug in our numbers. A2 will equal 11,098.5 over 1590. And what we'll get from that is 6.97 meters a second squared. And essentially, we also want to make sure we convert back to g's, because our initial given acceleration was a g's. We can convert this back to g's as well. So our A2 will then equal 6.97 divided by mass of, or the gravity, acceleration due to gravity. So 6.97 divided by 9.8. Equals just about 0.71 g's after calculating that in the calculator. And that is going to be how you solve this question.